these three, let's start with the adsorption, right? So what exactly is surface chemistry? So it is that branch of chemistry in which we deal with the study of phenomena occurring at the surface or interface, right? That is the boundary, the surface or the interface that is at the boundary separating two bulk phases. So we use too many terms here. Bulk means uh, something which is in good quantity. That is called a bulk, right? So suppose there are different two different bulks, right? Say for example, it can be like this: a container having a liquid and air above it, the liquid. So now this surface which separates it, this is called the interface, right? And the two, these two, that is air and the liquid, they will be called your bulk phase. So this is bulk 1, this is bulk or bulk phase 1 and 2. So that constitutes a good amount of mass, and those two masses, when they are in contact, they will have a contact surface or surface of contact, that is called interface. And the phenomena or the boundary, and the phenomena or the branch of chemistry which deals with the study of different phenomena occurring at that particular surface or such type of surfaces, that is called surface chemistry. That branch of chemistry is called surface chemistry. Now in this surface chemistry, the first thing which we are going to study is adsorption. So this you have to be careful. This is D. It is not absorption. This is adsorption. So that is the first thing which we have to study, that is adsorption. So what exactly is adsorption? Now it is observed that there are certain solids, like for example say charcoal or silica, etc., which when added into a closed vessel containing some gas or to the aqueous solution of a solute, uh, some acid, the molecules of the gas or the solute from the solution are attracted towards the surface of the solid and then retained on the surface. So they don't go deep inside the bulk of the substance, they remain on the surface. As a result, the concentration of gas or the solute on the surface of the solid increases. Now, this similar phenomena is observed when a liquid is added into a closed vessel containing a gas. This thing is known as adsorption, right? So the phenomena of concentration of molecules of a gas or liquid at a solid surface is called adsorption, right? So I mean, the most common example you must have even observed yourself is a chalk piece in ink or water. That is, what do we have here? Here we have a solid mass and a liquid mass, right? And there is a boundary for that. So if this is the chalk and if it is dipped in ink, right? So what we observe is, and after that you just take it out, then you will see that the ink is, and then you break it from any point and you observe its cross section. So suppose if the ink was blue, right? So the blue color will be there only on the surface or little inside the surface, but not, there will be a mass of the chalk which will be still of white color like this. This is adsorption. So the concentration of the liquid was more or becomes more or increases at this surface of the chalk piece. This is called adsorption. So the phenomena of attracting and retaining the molecules of a substance on the surface of a liquid or solid, resulting into a higher concentration of the molecules on the surface, is called adsorption. Now the substance, there are different substances involved here. So what are those different substances here? The substance absorbed on the surface. So suppose we have this solid. It can be even liquid, but for the timing we take this example of solid. And suppose concentration of a liquid increased on top of this. Let us show this by this. So it is only on the surface or the interface, and it is in bulk. This liquid is there like this. It is there all around that solid, but it got absorbed on the surface, right? We say adsorb, ADSORBED. This process is called adsorption. Now the substance which got attracted or adsorbed by the surface is called adsorbate. So this substance which got adsorbed, this will be called adsorbate. Right? And the substance on which it is adsorbed is called adsorbent. So this is adsorbent. Right? So this is the difference. On which the adsorption happens, that is called adsorbent, and where or the substance which gets adsorbed is called adsorbate. So this has got adsorbed, and this is the substance on which it is absorbed, that is called adsorbent. Now there is even a reverse process, that is removal of the adsorbed substance from the surface. That is called desorption, right? So adsorption is attraction of a substance on surface of another substance, right? So the substance which is get attracted, so what name we gave this substance? We gave this substance name of adsorbate. And what was this substance? This substance will be called adsorbent, right? So that's what adsorption is. And there is another process that is called desorption, DESORPTION. This desorption is nothing but, instead of attraction, we'll say removal. Of adsorbed substance. From where? From a surface of adsorbent. So this is called desorption. Desorption is just opposite of adsorption, right? So these are the two phenomena. Now, as From this, we can easily say if the surface area will be more, obviously greater will be the adsorption. So that is one thing. Now there is a special type of adsorption, that is adsorption of gas on metals. Gas on metals. If that happens, this is a special case, that is adsorption of gas on metals, and this is called occlusion. That is OCCLUSION, occlusion. Right, so these are different types, different words or terms which we see, and then in daily life where we see, right? So that is adsorption. Where do we see these adsorptions happening in our day-to-day life? So we see this happening in many places. Say the first example with which we started, that is example of charcoal. The solution of organic dye, say any dye, blue color dye, or uh, to that solution you add an animal charcoal and you stir it. Now it is observed that the intensity of the color in the solution decreases. So there is some animal dye, sorry, not animal dye, animal charcoal. To that animal charcoal, or add that animal charcoal in organic dye. Dye means color. And we see that the intensity of color decreases. Intensity of color decreases. Then what does it mean? It means that from the color, some particles which actually were responsible for giving color to the dye, they somehow their concentration decreased in the color or in the dye. That means they have gotten settled somewhere, and where they have settled on this charcoal, right? So that is one example. Next we have, when we introduce finely divided solid into a closed vessel containing a gas at low pressure, the pressure of the gas is found to decrease. So a vessel containing a gas, in that vessel now you add some finely divided or powdered solid. What do we observe is the pressure of gas goes down. That means the gas particles are now less. The In a closed container or a vessel, pressure of gas is nothing but the force with which the gas molecules hit the wall of the container. And if the pressure is going down, that means now the number of particles of gas has decreased, or you can say that the concentration of the gas molecules or gas is now less. So its concentration in the gaseous phase has decreased. That means what happened? Those molecules must have went somewhere. Where it go? It went into these finely powdered or powdered solid. So why finely powdered? Because when we powder it, right, when we divide it or when we break into smaller pieces, so by dividing it into smaller pieces, we increase the surface area. And we have already seen that this adsorption happens on surface. So more the surface area, more will be the adsorption. So that's why these vessels will show us, I think, the pressure of the gas in the vessel will decrease. Right. So that was the second example. Now, third example is actually how the sugar is refined. That is, sugar refining. How does that happen? So the raw sugar, I think nowadays you must have seen in market also, you will find raw sugar. So the raw sugar is actually little brownish in color. You must have seen organic sugar nowadays, they are very common. So this raw sugar is light brownish in color, but the sugar or the refined sugar is pure white. They are actually white crystals. That means this raw sugar had some uh, not impurities, actually they are nutrients, but little dark or brown in color, right? And so what they did is they wanted to make it or more sellable initially. So what they did is the sugar, whatever we got, they wanted to refine it. Now, in order to refine it, what is being done is this raw sugar is made to pass over animal charcoal. Again, the same animal charcoal which we have seen earlier in the first experiment. So again, the same thing, that is animal charcoal. So again, finely divided animal charcoal, these charcoal absorbs the impurities or those brown colored nutrients from the raw sugar, and then we get this white crystals, pure sugar, which has only sugar but no nutrients, right? So that is how the sugar is refined. And again, there also the phenomena which helps us do that or achieve that, that is called surface chemistry. Now you must have also seen silica bags. Where do you see these silica bags? In your water bottles or containers. So there you will see a small bag, right, like this, and that bag has some granules in it. Those are actually silica gels. The purpose of those gels, those balls, small balls, is to absorb the moisture. So this absorbs the moisture. Why we need it? So that moisture is absorbed and there is no scope or little less, or you can say less scope of growth of new microbes which can grow in that moisture if there is a moisture, right? So these are the application or real life, you can say, things or events where you see adsorption in action. Right. So now let's move to our next topic, that is mechanism of adsorption. How does it happen? Adsorption mechanism. The mechanism behind adsorption is again mostly it is based on the molecules force of that attractive forces between these molecules. The situation existing at the surface of a liquid or a solid is different from that in the interior, right? So whether it is a solid or whether it is a liquid, uh, it doesn't matter. Uh, the surface, suppose this is a container and in that there is this liquid, or suppose this is a solid. Doesn't matter. In the both the cases, we say that this part is bulk. This part is bulk. And this is surface. And this is also surface. This. All this is surface. But inside it is, the inside part will be called bulk. Right? And now what happens here is the situation, as we can see here, inside the liquid or in the bulk of the material or solid or liquid is different from the interior. And what does that mean? That a molecule in the interior of the liquid is completely surrounded by other molecules on all sides, and hence the intermolecular forces of attraction are exerted equally in all directions. So if I consider a molecule in the liquid, that is in the bulk, so there are identical liquid molecules all around it. So the forces which it will experience, right, they will be equally in all the directions. So it will get attracted by the nearby molecules in all the directions, and those forces will be equal. But that is not the case with the liquid which is near the surface. As you can see here, the intermolecular forces of attraction by the liquid is this. The liquid molecules will be this. There won't be any such force of attraction by its own neighboring molecules above the surface. So a molecule at the surface is surrounded by larger number of molecules in the liquid phase and fewer molecules in the vapor phase. So there will be vapors of the same liquid in the vapor phase also, but they will be very few. And because they are very few, this attraction will also be very less. Right? So as a result, these molecules lying at the surface experience some net inward force of attraction, which causes surface tension, which you must have studied, or yeah, that will come in the physics in fluids chapter. So you must have studied it last year. So as you can see here, due to all this, there is a net force on the surface. There is a net force downwards or towards the bulk, that is inward force of attraction, and this causes surface tension. So about surface tension, you must have learned surface tension is nothing but the force per unit length on the surface of the liquid. Now similar inward force of attraction exists at the surface of solid as well. So there is nothing different in solid. It is, you may not call it surface tension, but force here will be, the resultant of that will be inwards, and the solids which are the molecules which are here, they will experience similar force in all the directions. So that is the difference between the bulk and the solid. Just wait for a few seconds, I'll be back.